A function is continuous on the open interval from -infinity to infinity with zeros at x equals 5, x equals 0, and x equals -5. The functions f prime and f double prime have the properties given in the table below. Sketch a graph that satisfies the given properties of f. All right, so in order to begin, let's first graph our zeros that were provided in the instructions. So that's at x equals 5. So that's right about here. X equals 0 and x equals -5. Okay. And now we are given this information within our table, and we can use this information to make a rough sketch of what our graph will look like. So from -infinity to -3, we have a positive derivative, which means it is increasing, and the second derivative is negative, meaning it's concave down. So I'm going to adjust what I just drew here to have it showing up like this. So it's increasing and the concavity is negative, so it's opening downward. Then at at x equals -3, we have a derivative of 0, meaning it's an extrema, and we still have a negative second derivative, meaning it's still concave down. So, and we're switching from positive to negative. So that's going to make x equals -3 a relative maximum value. So I'll put that roughly about here, and it's going to look, we have that point there, and here we have it will decrease and still be concave down. So it'll look something like this in that next section. And then at x equals 0, we have continuing to decrease, but then the second derivative is 0. So that means that this intersection at the origin is also a point of inflection. And then to the right of that, we have still a negative derivative, meaning the function is still decreasing, but we have a positive second derivative, so it's going to be concave up there. And then we have a first derivative being equal to 0 when x is 3, and a positive second derivative, meaning it'll still be concave up, so this is going to be a minimum when x is 3. So at x is 3, I'm going to go a little further down, right at about here, to kind of make it look like a point of inflection occurs at the origin there. And then to the right of this relative minimum that I put in there, we have a function increasing again, and it has an upward concavity, so it'll look something like this when we sketch it. So we're coming up and we are approaching the x-intercept and the relative maximum. We have concave down, and then we're switching concavity to concave up, and then we're still concave up as we finish our function. And let's see how well we did with this. It's actually not that bad. I think I went a little higher than what this graph shows, but it generally follows the same pathway.